In last video, we see that how client A can connect to the server using RSA public key. In this video, I am going to explain how client A can talk to client B using our server. So for that, we have the DM handshake flow here. According to the protocol, client A must have the user ID of client B. Then only client A would be able to talk to the client B. First, client A will request for the public key of client B to the server. So client A will send a request packet to the server. Server will check if client B is connected to the server or not. If it is not connected, server will send an error. And if client B is connected, server will send the public key of the client B to the client A. At this point, client A has the user ID and the public key of client B. Now on the client side, we will generate one DM key and we will sign it with the private key of client A, and we will send the packet to the server. Now server has the DM key which is encrypted with the public key of client B and a signature with the A's private key. Now server will forward this all the information to the client B. Now client B have the public key of client A. Client B will verify the signature and decrypt the DM key which is encrypted by client B's public key. So now at this point, client A and client B, both of them have a common DM key, and server is not aware of that because DM key was encrypted with the B's public key. Now since client A and B both have the same DM key, both of them can encrypt the messages and only client B would be able to read it. Or client B will encrypt the message and client A can decrypt the message. Server is completely unaware of that DM key here. After the signature verification, client B will send an acknowledgement to the server and server will send the acknowledgement to the client B. And like this, the DM handshake completes between client A and client B. Let's check how the packet is encrypted. So we are using double encryption here. Let's say client A is trying to send hello world message. The message content is encrypted with the DM key and the whole payload is encrypted with the session key which is shared between client and the server. So server can read the payload, but server is completely unaware of the message content. Only the other client can read the message content. Now let's inspect all the packets between client and the server using Wireshark. So first let me log in to my server and start the null-talk server. Now I will connect two clients on the server. So let me apply the IP address filter and filter out all the packets coming from the server. So there are no packets right now. Let me connect the one host, one client. Okay, so one client is connected successfully. If we check the server logs, new client is connected with the ID RSA name. Now I will try to connect some other client with some other ID RSA key. This one is encrypted, so it is asking me for the password. Let me enter the password and then we can continue. Okay, so new client. So there are two clients right now connected to the server. So let me explain how the user application is working. So it has three modes. First is normal mode. In normal mode, we can switch the sidebar and the main panel. And there are another mode like command mode. If we press the slash, it will enter into the command mode. And there is one command said my -id. So it will reveal my user ID. Same I will do from here. So this is how I can get my user ID. Now we can share this user ID with another user so that they can send us the DM request. So what I will do, I will copy this ID, and from this client, I will try to establish the successful DM session. So first let me copy the DM ID. Okay, in the command mode, there is a command name DM space, and we have to paste the user ID of the user. Okay, so before pressing the enter, I will just clear the Wireshark packets. Okay, so as we can see, the DM session is created, and on the other client side, we have one session on the side panel. So we will switch to the side panel using arrow keys, select the session, and press enter. So now this ID RSS session is active on the both client side applications, and we have captured some packets here. So first, client running on the port 63194 is pushing one packet to the server. This is probably the request packet where client is requesting for the client B's public key. In the second packet, server is sending some messages to the client running on the 63194. And this is the public key, and it is encrypted actually, so we cannot see this. Client will send, okay, this is acknowledgement. And in the next packet, client will send this thing. Client will send the DM key and the signature. So this packet is sending the DM key and the signature. If we check the payload length, so payload length is around 1246. So this one contains our DM key and signature. Server will pass this packet to the other client. If you check, one client has the port 63194, and this is the other different client 63197. So server is sending this message to this client. Okay, this is I guess acknowledgement packet. This is the actual uh, packet being pushed to the other client, and 97 is sending a success request to the server, and the server will pass the success response to the 94 client. And these are the acknowledgement packets. So this is the complete flow of DM handshake. These are the packets being shared between client and the server. So let me clean this up and send some messages. Now I will try to send some messages from IDRSA client to the byte master. So as you can see, this hi message is delivered on the other side with the same text, and there are 4 packets exchanged between client and the server. So the client with the 94 port sends a packet to the server, Server decrypts it, read the user ID, and pushes the packet to the 97 client. Let's check some other scenario. Let's say I'm trying to connect with this user, but this user is not connected to the server. Let me close the connection. Okay, so the client is not connected, and if I try to send the message, hi, I will get one message that the client is not connected. So this is the error message. And if I try to establish a DM connection, so the other client is disconnected, I will clear the packets. And if I try to say the DM command, I will get this error saying client is not connected. So in that case, we have only three exchange of packets. First, client is asking for the client B's public key to the server, and server pushes a message that client B is not connected. The connection closes.